In our last lecture and tutorial, we began looking at objects and classes in C++. This presentation will look at more aspects of objects that we haven't studied yet. The last topic that we studied in the lecture was the this pointer. Recall that you can have many objects of a class, and the this pointer is how C++ knows which object was calling a member function of a class. This presentation continues on with section 19 in the workbook, and the topics that are covered include arrays of objects, destructors, and dynamically allocating objects on the heap. As we study these topics, we'll use the following class. The class is called car and has three member variables: make, year, and price. And along with those member variables, it has four public member functions, two constructors, and remember constructors always have the same name as the class and don't have any return value. In this case, one constructor takes a pointer to a character for the make, an int for the year, and a double for the price. And the second constructor is the default constructor, which takes no arguments. Finally, there's two functions for accessing the make, one get function and one set function. Notice that the get function has a const at the end of the prototype, which means that it's not allowed to change any of the member variables. So now that we've seen the interface or the declaration of the car class inside of car.h, let's see the implementation in car.cpp. As usual, the implementation file or the CPP file includes the interface or declaration file, in this case car.h. Because this class will use some string standard library functions, cstring is included. This is the same as including string.h in a C program. It will also use the assert macro to check that the requirements of a function are being met. For that reason, cassert is also included. Now let's look at the default constructor, which has no arguments. Remember that if you implement a function for a class in an implementation file outside of the class declaration, you must use the scope resolution operator to tell the compiler which class the function belongs to. In this case, you see car : and then the function name, which is car as well, since a constructor uses the same name as the class. The : being the scope resolution operator. In the next line, year and price are initialized in the member initialization list, which begins with the colon at the beginning of the line. Since the initialization for make is more complicated, it has to be placed inside the body of the constructor. In this case, each element of the array is initialized to a null terminating character. And now the second constructor takes arguments and initializes year with y and price with p. Next, it asserts that the length of a string that is passed in to the m pointer is less than the maximum size, which is defined as size. In this case, it was 20 characters. If that condition is met, the string is copied from m into make. And finally, the last two functions are implemented. As with most get functions, it's a simple return statement for getMake, which returns the make of the car. The set function checks that the length of the passed-in string is less than the maximum size, and then copies the string into make. Accessor functions, or get and set methods, are usually very simple, as in this example. Now that we have our car class implemented, let's see how we can declare an array of objects. Actually, this is very similar to how arrays of structs were declared in C. You'll see in the main function, we simply put square brackets after declaring the variable x, which is of type car, and inside the brackets, we declare how many objects we want in the array. In this case, there's 3. Remember that arrays are of constant size and shouldn't be initialized with a variable size. Each element of the array gets default constructed, or the default constructor is called for each element. This is always the case with arrays of objects, since C++ doesn't allow you to pass arguments to each element of the array. Now take a few moments and try to draw the memory diagram at point 1. And here's the result, the memory diagram at point 1. As always with arrays, we start with the lowest index on top and higher indexes below. What's new with classes is that the default constructor has been called on each object. So instead of being initialized with question marks, we know the value of each variable. For the car class, the default constructor simply initializes year and price to 0, and each element of the array for make to a null terminating character. Now let's see how to access elements of an array full of objects. As with any array, the square brackets are used to indicate which element of the array you want to access. What's new with classes is that now we can access an element of the array and call a member function on that element. So in the line x square bracket 0 dot setMake, we're calling the setMake function on x0. Or in other words, the this pointer inside of setMake would be pointing back to x0. With that in mind, try to draw a memory diagram at the end of the setMake function for the first time it's been called. Here's the memory diagram at the end of setMake for the first time that it's called. Remember that the this pointer is like the first argument, but it's a hidden argument to any class member function. In this case, the this pointer points to x0 because we called the function using the statement x0 dot setMake. Now, if you were asked to predict the output of the program, the first call x0 getMake would output Honda, and the second statement x1 getMake would output Ford, but because we have square brackets at the end, we're only accessing the first character, which is just capital F. And finally, the last topic to cover regarding arrays of objects is how to pass arrays of objects. There's nothing special here, it's just like passing any other array. And in this question we have the function displayAll, which takes the array of cars and the number of cars to be printed. There's also the swap function, and you're asked to write the implementation of both functions. So go ahead and attempt to write the functions on your own. Here is one possible solution for the displayAll function. Notice that the x argument gets passed in using the square brackets to indicate that it is an array. The second argument indicates how many cars to be printed in the array. And the only function that we can use for getting details about the car is getMake. So inside the for loop, we print the car number, which is j, and we also call xj.getMake, which will return the make of the car. And the swap function is very similar to any other swap function. The one thing to note is that when we do temp equals star x, all of the values of the members of x get copied into the members of temp. That's referred to as a member-wise copy. And now let's look at the next topic in the section, and that's destructors. You can think of a destructor as the opposite of a constructor. It's a special member function of a class. In contrast to constructors, which get called when you first declare an object, the destructor gets called when an object goes out of scope or when delete is called on a pointer to an object. The destructor can be called directly, but it's not recommended and almost always is automatic call. Like constructors, destructors have no return value. But unlike a constructor, which can have arguments, the destructor always has no arguments and consequently there is only one destructor function. And as we've seen in the previous examples, it's not always necessary to define the destructor yourself. The compiler will generate a destructor automatically to remove the memory used by an object on the stack. However, if your class allocates memory on the heap, a great place to call delete on that memory is inside of the destructor. We'll see an example of this with the following person class, which has two member variables, age and name, except the name is now going to be stored on the heap. Because the destructor automatically generated by the compiler will only remove the memory on the stack, we need to explicitly define a destructor so that we can get rid of the memory on the heap. So you'll notice the prototype for the destructor in the member function list. Here we see how the constructor and destructor get implemented. Inside the constructor, the new operator is used to allocate a character array on the heap. And because we're using memory on the heap, we must call delete on that memory. So in the destructor, which is always the function with a tilde and then the name of the class, in this case tilde person, the delete operator is used to free the memory on the heap. And in this case, we're using the array version because we allocated an array. You can tell it's the array version because there's empty square brackets after delete. And now for the last topic of this presentation, allocating objects on the heap. And as we saw in the previous example, the new operator is used to allocate memory on the heap. Any type of variable, including objects of classes, can be allocated on the heap. If we switch back to the car class, in this main function, two pointers to cars are declared, x and y. And x is initialized to point to a single car on the heap, whereas y points to an array of 3 cars on the heap. And we'll see what this looks like in a memory diagram. And here we see it, x pointing to a single car on the heap, and y pointing to an array of 3 cars on the heap. Both of them have been initialized using the default constructor. For the arrays, it has to be using the default constructor, but x could have been initialized using any constructor. That's only a limitation for arrays, that they have to be constructed using the default constructor. And just like everything else that gets allocated on the heap, objects that are allocated on the heap should be deleted. In this presentation, we reviewed much of what we learned with objects already, and we also introduced the ideas of arrays of objects, the destructor for objects, and there is always only one destructor. Gets called when an object goes out of scope, or when delete is called on a pointer to an object. And this presentation finished by showing that objects can be allocated on the heap using new and delete, in the same way that any other type can be allocated on the heap. In the next presentation, I'll go over the solution to tutorial number 8 in the workbook. That tutorial reviews all of the concepts that we've covered so far regarding objects. Now is a good time for you to attempt tutorial number 8 before advancing to the next presentation.